Okay, folks, so here's the second part of the SAS congruence relation and CPCTC. This is a little more formal treatment of it. Before you start a proof, though, you really need to investigate what's going on. And you do this informally, and then you write up your formal proof. So my informal part is that I look at B and I look at what's given. It says B is the midpoint of DC and AE. So since B is in the middle of DC, then I know that these two sides are equal and congruent. Equal and congruent are almost interchangeable. A geometry teacher will argue that, but I'm going to suggest that they're interchangeable. That when I'm saying CB is equal to BD, it's the same as saying that they're congruent. The same thing is true for the segment AE. We know that B is in the middle, so that means the two segments are equal. We also know that we've got vertical angles here. And vertical angles, if you've ever used a pair of scissors, you can do a literal visual proof of vertical angles are congruent. Let me show you what I mean. If you grab a pair of scissors, most of us are aware that when you open one side, the other side opens the exact corresponding amount. And there's your proof of vertical angles are equal. I have a better proof of it on the channel. But anyway, here we go. So vertical angles are equal, which means that angle DBE is the same as CBA. So now we have a side angle side, which means that we're looking at congruent triangles. Well, if we have congruent triangles, then all the parts are the same, and AC and DE are corresponding parts. So that makes them congruent. So that's what you do before you start your proof. Then you actually write it up formally. So we start with our given. Then we say that since B is the midpoint of DC, then we know that DB is congruent to BC. And I'm going to write this at the exact same time. I'm also going to do AB is congruent, is congruent to BE. And I'm using the same logic in both cases. I'm saying that I'm using the definition of midpoint. Midpoint says that you're in the middle. Now, most geometry books would start with the sides are equal, and then that means that they're congruent by definition of congruence. But I would just say they're congruent because B is the midpoint, and that's what it means. And we're talking about the definition of midpoint. We know that angle ABC is congruent to angle EBD because we know that vertical angles are congruent. Man, I'm almost done. Look at that. So now I know that my two triangles are congruent by angle, side, angle. I've got an angle, a side, and a side, an angle, and a side on each of the triangles. So we can say that triangle ABC, and it's important that you write these in order. Notice that A is that small angle and E corresponds to A. So I need to write the E first, and the B is in the middle, and the B is next, and then the D is next, isn't it? It's important that you write them in the order that they appear, because that way you can read the different parts. AB, for example, is the same as EB, and BC is the same as BD, and so on. So this is by side, angle, side, congruence relation. Finally, we know that our parts, if the two triangles are congruent, then the part AC is congruent to the part DE. Now you'll notice that these are backwards, but DE is the same as ED. And 5, that is by corresponding parts of congruent triangles are congruent. And there you go. I didn't want to spend too long on that. So I hope you got it. That's a little more formal treatment. And now I have the next one is going one step beyond that, and we'll try a little bit harder one. So see you then. Bye.